Section 6.1 exercises. Problem 1. We're asked to verify or prove the identity, the cosecant of x times the tangent of x is equal to the secant of x. What we'll do is start on the left side and we'll rewrite each term so that it is in terms of sines and cosines, and eventually we'll end up with the right-hand side. So by definition, the cosecant of x is 1 over the sine of x. And by definition, the tangent of x is the sine over the cosine. By multiplying top and bottom, we get sine of x divided by sine of x times cosine of x. Since we have multiplication in the denominator, we can divide out our common term in the top and the bottom. That leaves us with 1 over cosine of x, which by definition is the secant of x. So always we want to start by working only on one side, never crossing over to the other side, and working on that until we arrive at the other side. Let's take a look at problem number 2. Verify the following identity. Okay, we'll use the same technique as we did above. We'll write cosine of x. By definition, the cotangent is the cosine divided by the sine. And then we'll add to that the sine of x. Never cross over the equal sign. Always stay on one side and arrive at the other. So we'll multiply here, top and bottom. This is cosine x divided by 1. So that'll give us cosine square x divided by the sine of x, plus I'm going to write sine of x divided by 1 in preparation to add this together. So to find a common denominator, we'll multiply this by the sine of x over the sine of x. And now we'll have a common denominator, sine of x and sine of x, so we can now add the tops. Cosine square plus sine square, all divided by sine of x times 1. Now we can use the Pythagorean identity. The cosine square of x plus the sine square of x is 1. And 1 divided by the sine of x is, by definition, the cosecant of x, and we have arrived at the right-hand side. Let's go on to problem number 3. Verify the identity. Sine of x minus the sine of x times the square of the cosine equals the cube of the sine. So here, often there's algebra involved, and everything's written in terms of sines and cosines. So what we'll do is we'll factor out the common term of sine x on the left side. And we have left 1 minus cosine square x. So that's an algebraic move. Now the Pythagorean identity, sine square x plus cosine square x is 1. But from there, we can also rewrite this in terms of sine square x as 1 minus cosine square x. That's just rearranging the Pythagorean identity. Why did I do that? Because now we can replace 1 minus cosine square with the sine square. So this second line becomes the sine times sine square of x, and by multiplying the two together, we have arrived at sine cubed of x, which is the right-hand side. Problem number 4, verify that identity. Okay, often there's more than one way to go about it. Sometimes it's an arithmetic move, sometimes it's an algebra move, and sometimes it's a trigonometric move. Here, I think what we'll do is an arithmetic move. We'll separate this fraction into two pieces by writing both terms in the numerator divided by the same denominator, which is sine of x. 1 over sine of x plus cosine over sine, separating the numerator so that we have a common denominator. Now, by definition, 1 over the sine of x is the cosecant. I keep saying x, but our variable here is theta. And by definition, the cosine of theta divided by the sine of theta is the cotangent of theta. So one arithmetic move here by separating the numerators allowed us to prove the identity. A different way to go about it, perhaps, is to start on the right side and rewrite it so it ends up being on the left side. By definition, the cosecant is 1 over the sine, and by definition, the cotangent is cosine over sine. Now, since we have a common denominator, we can add the tops and use the denominator just once, and we've arrived at the left side. And it's fine to work either side separately as long as we don't cross over the equal sign. That would assume that what you're trying to prove is already true. Let's try problem number 5. Okay, so what am I thinking? Already in terms of sines and cosines on the left side, we generally start with the more complicated side, so that would be the left side. But I do see two fractions that I can add together. So I will find a common denominator and add them together. So rewrite this first fraction. And my common denominator will be the product of the two. So this fraction gets multiplied by sine of x over the sine of x. And this fraction here needs 1 plus cosine x in the denominator. So we'll multiply by 1 plus cosine x divided by 1 plus cosine x. So we are multiplying each fraction by 1, which does not change its value, but it will change how it looks. Multiplying here, we'll have sine square in the numerator. And I'm just going to write as a product my two factors in the bottom. And then here we have 1 plus cosine times 1 plus cosine. It's 1 plus cosine square. And same product of factors in the bottom. Okay. Now we can write this as a single fraction with the same denominator. And I will do that. And the other thing I will do is multiply out 1 plus cosine x in the numerator and see where that leads us. So I have sine square x from this term plus. Now we expand the binomial 1 plus cosine of x all squared, and we get 1 plus 2 cosine x plus cosine square x. So that's expanding the binomial a plus b, the quantity squared, is a squared plus 2ab plus b squared. Okay, now what do I observe? Sine square x plus cosine square x is 1 by the Pythagorean identity, plus the 1 that's already there, plus the 2 cosine x that's already there, and we have the same denominator still there. Often we do not multiply out the denominators, but we usually do in the numerators. This is just a general rule of thumb that seems to work for most problems. Now 1 and 1 is 2, so I'll use a little ink to make a simple maneuver. To get us the next line. Now we can factor out a 2, common factor of 2 in the numerator, and now we have 1 plus cosine of x. And in the bottom, perhaps now you see why I did not multiply out the denominator. We have a product here, and we have a product here, so now we can divide out 1 plus cosine x, and that leaves us with 2 in the numerator, sine of x in the denominator, and by definition, 1 over sine of x is the cosecant. So this will give us 2 times 1 over the sine of x, or in other words, 2 cosecant of x, which is our right-hand side. And that's the end of section 6.1 problems.